Hello, everyone, and welcome to the latest podcast broadcast of This Week in Science. We are back again, as we are every Wednesday, 8 p.m. Pacific time-ish, to talk about all the science that happened within the last week. We have a wonderful guest tonight, and as usual, I would like you to know that this is the live thing. I mean, even if you're watching it on the YouTube, Facebook, or Twitch stream, this is recorded live. There's no edits here. This is as it is. So if you want the edited version that takes out some of the ums and the ahs and the technical difficulties, please subscribe to our podcast wherever you find your podcasts. Click the like, subscribes, etc. Let's go with that algorithm because it's time to start the show. You ready, kids? Yes, everybody nods their head. Yes. Yes, we like to start the show. Let's make it go. All right. Starting in 3, 2. This is TWIS. This Week in Science, episode number 981, recorded on Wednesday, August 7th, 2024. Will science take us from tropes to hopes on this oblate sphere-oid? That was a terrible title. I'm Dr. Kiki, and tonight on the show, we're going to... What?
I like it. Double down with it. It's good.
I'm doubling down our oblate sphere-oid. Yes. Tonight on the show, we are going to fill your heads with cat love, streetlights, and racehorse guts, and a climatic interview. But first...
Disclaimer. The world is ready for a change. Not ready in the stocked up on emergency supplies, packed a snack, plenty of water, extra underwear sort of ready, but in the stocked up on greenhouse gases, melting ice pack, plenty of sea rise, extra heat sort of way. The tipping point has already happened. The change is coming. And while there's nothing we can do about it, there is nothing we are currently doing that would be enough to avoid it. The change is coming. The future will be different. Some islands will disappear. Coastlines will be rearranged. The climate change will alter the survivability of plants and animals. Habitats will shift, relocate, transform, and will establish new biomes. With the change will come tremendous loss and unique opportunities for success as life finds a way under a new climate landscape. All of this has happened before and will happen again, only this time the modern human civilizations will be part of it. And our one chance to be ready for it depends on This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
We forgot to tell our guest that there's a dance segment that is part of the show.
I didn't practice some moves. I was like, I don't know. Should I be doing this to compliment them? What is the move that meshes?
Oh, welcome everybody. Freeform. Welcome. It is freeform. Freeform dance your PhD. I don't know. Welcome to another episode of This Week in Science. Everyone out there, Justin, Blair, Dr. Fischer, Emily, and everyone else, thanks for joining us. We have an amazing show ahead, as always, and it's going to be full of science that we've brought to you that we thought worth talking about, and an interview with our guest, Dr. Emily Fischer from, I'm going to get this one right, from Colorado State University in Fort Collins, because I wrote it down wrong initially, apparently. Dr. Fischer is also a science mom, so I'm very excited to bring her on the show. On this week's show, I have tons of stories about cats and those they love, crushing concrete for good. I've got some little tiny dog brains and maybe some earbuds for your fatigue. What do you have, Justin?
Oh, that's a very good question because I prepared this before I had slept, so now I have to go and see what did I bring. But
Your
it's
dreams.
the greening of Greenland, stranded in space, and smaller hobbits before Homo floresiensis.
Even smaller, like
Even
Barbie dolls.
smaller.
Oh my goodness. Blair, what is in the
Not quite. But,
Okay.
yeah.
We'll talk about it. Blair, what's in the animal corner?
Oh, I have thick leaves. I have horse guts, and what was the other one? Oh yeah, sea lion photographers. We've
had what was it, a gorilla or chimpanzee photographer at one point in time? So
the one that PETA sued over, that was a monkey.
a monkey.
It was a macaque,
Copyright
wasn't it?
issues. Yeah, who's the photographer? Who's in charge? I don't know.
Yeah.
Can't wait to hear about it. And then we will be speaking about the climate, about the work that Dr. Fischer does on the troposphere. What's the troposphere? We'll find out soon. Right now, we're going to jump in, but I want to tell you again that if you would like to subscribe to This Week in Science, you can find us all places that podcasts are found. We are broadcasting live weekly Wednesdays, 8 p.m. Pacific time on YouTube, Twitch, and Facebook. And our website is TWIS.org, where you can find show notes and links to all sorts of things that we discuss in the show. But let's talk about some of this here science. Cats, those independent creatures that people think have no feelings and just want to take advantage of us always.
Vectors of parasites that plague mankind.
Yeah, and also
They domesticated us as opposed to us domesticating them. Yeah.
Right. Everybody seems to think cats, they don't care about anybody, but they appear to grieve. They do. Some United States researchers just publishing from Oakland University in Applied Animal Behavioral Science have studied cats suffering from grief. When they had cats that were exposed to situations in which those they loved, whether they were dogs or caregivers or others, the cats were profoundly affected. The researchers say they engaged in less sleeping, eating, and playing, and more attention seeking from humans and other pets. Hiding, spending time alone, and then also appearing to look for their lost companions. So the feelings. Why are you laughing?
No, I'm just still suspicious.
No, they've just been playing coy their whole lives.
Is that it? It's just the mask has fallen.
They're masking. Maybe that's what it was. Maybe they're just, they felt like they needed to hide their true feelings the entire time. I don't know. All you dog owners who feel like the dogs are the only ones who care. Yes, well, that's not the way it is. Oh, and by the way,
I think I know why they're hiding. They ran the logic and they're like, I've got to be the number one suspect in this disappearance. They're going to think it's me. I'm going to lie low for a while until this blows over.
Has passed, but it is their job to take care of the remains, right? Isn't that the deal?
Oh, you too. Both of you dog people. I can't even with you.
I'm not even a dog person. I'm like a horse
No,
person.
he's certainly not a dog person.
I know that my cat will lie where I sit on the couch, not eating, until it wastes away after my death. They'll be grieving, I think. Anyway, your dogs have small brains because they're domesticated. That's just the way it is. Research out of the Department of Zoology, Stockholm, Sweden, has actually challenged this notion that domestication is the driver of reduced brain sized in domesticated animals, dogs specifically. But By doing a comparative phylogenetic analysis, they looked at a whole bunch of different canid species, and while it was kind of thought that domestication reduced the brain size of the dogs, it's kind of like the dogs that ended up with us already had kind of small brain size. So
this is relative to body size, because dogs are smaller than wolves, generally speaking. Okay.
Comparing phylogenetically compared to their ancestor, the gray wolf, Canis lupus.
All right.
Brain size and body size data for 25 canid species were compared. Interestingly, the common raccoon dog, which is not a canid, by the way, it hibernates, and it has it's more of an outlier in terms of brain size reduction. So maybe low metabolic activity and food scarcity constrained brain size in that particular animal. And maybe it also highlights other factors that aren't related to domestication, but that could also have been ecological adaptations that led to reductions in particular species brain sizes being smaller, like your dogs.
So wait, but it's still domestication, right?
Now, yes, domestication still does reduce brain size.
But the dumb ones were the ones dumb enough to be domesticated, is basically what this is about, right? Their brain size was smaller before they were domesticated, is what you're saying.
Because then, like, they're breeding. Because there was, like, I'm still trying to picture the time in ancient times when the proto-Chihuahua was hunting in vast packs upon the plain to bring down a wildebeest. Like, I think
it wasn't.
Like, all of these. No,
it was like the cats in Egypt going, "Where's my nice, soft, warm lap?"
Domestication and breeding.
That's my other question: is sort of what you want to know what regions of the brain? Because I would be curious like the region of the brain that lights up when they're communicating with a human, when they're taking a verbal command, when they're doing all these, following a point. Those are things that domestic dogs do that wolves don't do. So do they have larger areas of their brain for those things and smaller areas of the brain that light up related to like survivability in the wild?
It's possible, but all of it's smaller overall. Just saying.
And then picturing a wolf watching a pointing dog and just kind of going.
Shake your head.
So disappointing.
Yeah. Well, speaking of hunting, we're all hunting for that magic silver bullet, the single universal vaccine, the thing that's going to keep us from getting whatever muck is going around. Coronavirus, it's going around right now. The flu, it's going around. Can we stop? Last week we talked about specific immune cells in the nose and the nasal cavities, which are related to creating very specialized immune memory responses. This week, published out of the University of Houston, published in Nature Communications, researchers have come up with a couple of new ways of preventing respiratory viruses, so preventing and treating, and their nasal sprays. So they developed and validated what they call NanoSting, a nasal spray. It's an immune activator controlling infection against all sorts of respiratory viruses. So it's like, it comes in the nose says no. And then there is also NanoSting SN, which is what they call a coronavirus nasal vaccine against all members of the coronavirus family. Together, the two of these could potentially create immunity, allow immunity in an ongoing fashion, easily administered to people around the globe to allow us to be protected from these respiratory viruses that cause continuing and ongoing issues with our health. I think it's very exciting.
Very cool.
Yeah, like nano flu, but it's better. NanoSting. And also, okay, we're going to be talking about climate change kind of stuff. And I met this woman this last week who works in sustainable architecture. And she actually came from France to Portland because Portland, Oregon is a really on the cutting edge of reuse of materials. And there's something not related to what she's doing at all, but kind of. University of Tokyo researchers have taken blocks of carbon dioxide concrete from buildings that they have demolished. They've got a new kind of concrete that they are developing to use and soak in carbon dioxide and also not produce a lot of it. It's named C4S, calcium carbonate circulation system for construction. And they have now developed a method to combine the old concrete with carbon dioxide from the atmosphere, crush it all up, and create a new concrete material that's really strong so that we can keep taking old buildings, take the old concrete, crush it up, reuse it, and actually pull carbon dioxide from the atmosphere in the process. Fingers crossed that this is something that will work as well as the paper makes it look like it will.
And this is what you would call long-term strategy. Because if you think about it, pretty much all of our modern concrete buildings are going to need to be replaced in like the next 100 years. It's going to have to all recycle through because it's not.
So many of them.
It's not like the Roman Colosseum concrete formula that we're still trying to figure out. It's a much more temporary version that we've built everything with concrete out of, and so yeah, that's actually a major impact that it will have in the long term.
I have a quick question for Dr. Emily Fischer, who's sitting here listening and has been going, I don't know about these stories that you're talking about, but circular economy, it's really not a big topic of conversation among the general public here in the United States. I spoke with people from France, from Finland, from Sweden. The EU is all over the circular economy. What are we doing wrong? How do we get that? Do you see it being communicated more here than it has?
Do I see circular economy being communicated more here?
In the United States?
I have a biased view on this.
Thank you.
And so I don't think you should take my opinions on this at all. So my husband does supply chain sustainability for his profession. So in our house, circular economy is something that is talked about. But my perspective on it's not something I think about broadly. I think about it as I don't have a sense of how representative the discussions in my neighborhood in Fort Collins are as to the general public. But it makes me happy that you're talking about it, and the way to get things going faster is to talk more about them, as simple as it seems.
Yeah. I mean, I think what it really comes down to it is what you just kind of talked about is you don't know how much people don't want to think about these things. People don't want to care about what they're buying. They want to trust that what they're buying is okay, and then it's good. Mm-hmm. And so it needs to be built into the system. And
exactly. This is an us system problem, and we need to be able to trust our systems.
Yeah, I agree with that. Well, that's all my big headlines for the beginning of the show. Justin, how was Greenland last green? What?
Well, yeah. So this team of scientists have re-examined
Justin,
just a few inches
before.
Uh-oh.
Your mic sounds
your mic switched.
Like maybe you're on your laptop mic.
Did it really? Let me double check it.
Just before you do a whole story with the with
how did
audio.
It did.
Thank you, Blair.
So we're trying. Okay, so there was in 1993 a ice core dug right in the center of Greenland, and it went down about 2 miles. Various cores coming up at a time, but they went 2 miles down, and they stopped the last few inches when they hit dirt. And this soil got studied sometime later, and they discovered that, oh gosh, the sediment there could be less, based on the rocks, could be less than 1.1 million years since it was last exposed to the surface. And now other ice core samples from less central parts also showed exposure that was less than 500,000 years old. So there's been a few times when they say, oh, okay, so the ice cap has disappeared within, maybe not current modern human, but certainly hominin time spans. There's a current study now that's gone back and looked at those few inches of sediment from the central core site. And they've found that there are microfossils, some insect parts, some moss fungi, a pristinely preserved poppy seed from an Arctic poppy. And amazing. Being that this is in central Greenland, this suggests that very likely the entire ice cap had melted away. And again, confirming that it was within the last million years. So the study is published in the Proceedings of the National Academy of Sciences and is suggesting that the giant ice sheet is much more fragile than scientists had previously expected, although there's lots of current evidence in the last few years that's supporting that it's in line with. So what is especially wild about this is that there wasn't an unprecedented warming period when the ice cap would have melted, suggesting it takes a lot less heat to melt an ice cap than we are currently experiencing and currently heading into. What would this mean without the ice cap? It's approximately 7 meters of sea rise. Now, wherever you are, you might say, well, hey, I'm in the middle of Colorado. 7 meters of sea rise won't affect me a whole heck of a lot. It also means a lot more moisture in the atmosphere, which means more rain, more different climate in different places as the jet stream changes and as it moves different levels of moisture to different locations. Ultimately, we don't know what that full result is. Now, also, 7 meters of sea level rise for an island like where I'm on in Denmark seems real. No, well, that's going to be terrible. That's going to be above everything. However, there's this other effect that's going to take place because as this giant ice sheet melts away from Greenland, it's actually going to have a lot less weight pressing down on that land. And the buoyancy of tectonic plates would actually rise the Earth significantly in the Arctic region. I mean, Denmark might actually not get anywhere near 7 meters of sea level rise. But that also means that places
do we know?
Closer to the equator, further away from this rise, could get more.
Yeah.
It's not going to be uniform. Right now, currently, most of the world's population lives near a coast. And most of those coasts, if they're experiencing more than 2 meters, let alone 7 or more than 7, might everybody need to move, is what that means. But we're not talking, but again, this is the long distant future. This won't happen very quickly. This will happen, it'll probably take 100 years or longer. Right.
I was actually waiting for you to give the bottom line of like, it'll be 2050, which is
right now it's an inch a decade, but the rate at which sea level is rising is increasing quite a bit to where we will probably have over 1 meter or 2 meters by the end of century at this rate of increase. And then, I haven't really thought too much about moving up into the mountains, but keep in the back of your mind, if you're buying that real estate that you want to pass down to your family, put it way up high somewhere, because that beachfront property may be gone.
The beachfront property might be closer than you think. And I don't know, stock markets, whatever. Maybe just, mortgage rates are high, whatever. Maybe high altitude property inland is where it's at. I don't know. But then again, we have to think about the atmosphere and how that rolls into it.
Yeah. Might not be fun on the mountain.
Hopefully it'll be great fun on the mountain.
And then if there's, and then we can go into the next, or I can do a
the
quick,
mountain.
I've got a real quick one on the stranded astronauts.
Oh, yeah. No, yeah. They're still stranded.
Well, they're not stranded, according to NASA. They are just having an extended layover at an orbiting laboratory in space. Boeing Starliner launched on the 5th of June with 2 astronauts, Sunita Williams and Barry Wilmore. Their 8-day mission, which was a test flight of a craft that had not been manned before, to the 25-year-old space station, is now passing the 2-month mark. There have been issues with Boeing Starliner, the capsule that took the astronauts to the station. There's helium leaks and some sporadic thruster malfunctions that have made system reliability for the journey home too risky so far. 2 major reasons: the thrusters need to be fully functional to set up the critical re-entry angle into Earth's atmosphere so that the craft does not burn up. And 2, if there's an early failure, before Starliner gets far enough away from the space station, it could actually bump into the International Space Station, which would be also really bad. Boeing stated, confidence remains high in Starliner's return with crew. That was last week. NASA does not seem to be as confident at this point, saying no decisions have been made regarding Starliner's return, and the agency is working out an alternative plan to bring the crew home. That plan, the SpaceX mission to the International Space Station, is due to launch soon, I think next week, but it's been delayed until late September, early October now. That mission was meant to have a 4-person crew, but may launch with only 2 to make room for the stranded crew members. The question is then, how to get rid of the Starliner safely. Also, that mission, when it goes up, if it makes it up in late September, early October, is a 6-month mission. They have not yet determined whether or not they're scrapping that mission, which means the stranded astronauts may be taking over roles that were designated for the astronauts whose seats they're taking for another 6-month mission.
Well, at least they have had the experience in space so far to be trained in space.
Yeah. And I don't know how many people today.
There's of space travel really going well, huh?
Well, there's 7 people who have been up there already. Like the 2 that came up on Starliner were just visiting. They were meant to visit and go back home. There's a 7-person crew. My question is, like, what does the pantry look like? What is, like, are they rationing? Like,
they might be.
What is happening?
They probably
to the
have
whole
extra stuff,
food and water situation.
Snackers, but
no, I don't know, like, how well they stock that space station. Like, they must be, overstocked in terms of emergencies, but still.
Yeah,
it's stocked. They've got emergency supplies.
Boeing's had such a bad year. My goodness.
It's not just a bad year, Blair.
Bad few decades for sure. Yeah, you're right.
But tell me, let's move on from this and get into some. Did you tell us news about how you want to just leaf it all alone?
Yeah, leaf me be. Well,
bad puns.
Beijing. In Beijing, leaves are extra thick. Why? Streetlights. This originally came to researchers, they started looking at trees because the trees just weren't getting eaten by bugs. And so they were like, are the lights discouraging the bugs from eating the leaves? No, the leaves are thicker. Why are the leaves thicker when they're under streetlights? They don't know. There's a lot of ideas. It's from the Chinese Academy of Sciences, this research, but the prevailing theory is that either trees exposed to artificial light at night extend their photosynthesis duration, so they just keep getting thicker and thicker and thicker, or they might allocate greater proportion of resources to structural components versus size, because it appears as though they're not growing up, they're growing out. They're getting thicker instead of growing more leaves or getting taller. So there's still more research that's going to happen to figure out why exactly these leaves are thicker, but it's just for these 2 species of trees in Beijing. So very small sample size, very preliminary study. The leaves are thicker. And so it's harder for the insects to eat them. And of course, that is a huge problem for the food chain. That's a problem for all of these bugs. That's a problem for the animals that eat these bugs. So it's a new result of light pollution that we haven't really talked about before, making leaves thicker.
But we've talked about Alan before, and we have to blame it on Alan, don't we?
Yes. Yes.
Artificial light at night, people. Alan, your guy.
Alan.
Yeah.
It's Alan. Alan.
It's something that I hadn't ever really considered, the fact that this artificial light could be impacting the way that leaves grow, because you don't think of it as actual sunlight, right? That it's actually light that could be impacting the performance of the growth and development of plants, right? But only the birds, only the bats, only the insects. Why not the plants?
Right.
And now we see it's affecting them all. Alan. Alan, you're worse for the environment than Karen. I'm sorry to say.
Sometimes. Yes, sometimes. But what do? We have to get different hues of light. We have to use different, like the sodium lights people don't like. We have to find different frequencies. We have to do different things. So is that the question? The next question? Put lights on timers. Have areas with less lights that don't need as many lights. Don't light a soccer field that no one's playing on. Stuff like that.
All those things. Don't light the soccer fields that nobody's using. Okay. Those are the notes. This is This Week in Science. I do hope that you are enjoying the show, and I hope that you're not on an unlit soccer field trying to play your game of footy. But if you do love the show, please do share it with a friend and subscribe to This Week in Science wherever you do find podcasts. Right now, I would absolutely love to reintroduce our guest tonight, Dr. Emily Fischer. Dr. Fischer is a professor in the Department of Atmospheric Science at Colorado State University in Fort Collins, who studies the troposphere, how trace gases wind up in remote locations, and also self-cleansing aspects of the atmosphere. Emily, thank you for joining us on tonight's show.
Thanks so much for having me. It's fun to listen to you.
It was great to talk with you a bit, and I hope that this interview can be a conversation where we can get a little bit more insight into how you view some of these climate issues and things like the circular economy and also light at night. I don't know. You're an atmospheric scientist. Can we start with how you got interested in the atmosphere, what the troposphere is, why it's important, and why you focus on the things you focus on?
Sure. So we'll start with the troposphere. It's really easy. That's the lowest part of the atmosphere. That's where you live. It goes from the ground to about 6 miles up, or for our European rest of the world, never mind, not just Europe, the rest of the world, 10 kilometers up.
Let's use scientific notification, right?
After that point, the atmosphere changes, the structure changes, and that's where the ozone layer is. That protects us from the sun's UV radiation. So, but I study the lower part of the atmosphere, where we live and where we breathe, where most of the water is, where all the weather is. That's what the troposphere is. It's the part you feel. And I became interested in the atmosphere at a very young age, and I think it probably comes back to Hurricane Bob if I think about it. So I'm from Rhode Island, and so yes, Justin, when you were making jokes about moving to Colorado or Coloradoans who maybe don't care about sea level rise, I was like, well, my mom lives in Rhode Island, so I care deeply about sea level rise.
Yeah.
But anyway,
don't challenge her mom.
So anyway, I'm from Rhode Island, and Hurricane Bob hit when I was about 10. And I grew up in a house with a lot of south-facing windows, like this 80s passive solar design. And we had to board everything up. And when I think about that time, what struck me as a kid was the power and also the predictability that, like, we knew this was coming. Someone knew this was coming, and someone could tell my family that we should board the windows up and pay attention. And I thought that was just amazing. Because as you can predict something, when you really understand something at a fundamental level and you're able to predict it, especially with these disasters, you can prevent a lot of harm, right? You can protect people. And then, so that got me really interested in the atmosphere. And then I became slightly obsessed with air quality. And that started with worrying about smoking in the bathrooms, right? As a high schooler, I was like, this is gross, like breathing this is awful. And not really realizing at that time.
You were not a David Lee Roth fan? Is that what?
And at that time, I didn't realize, right, what ambient air pollution is, what that outdoor air quality is as much of an issue, right? And so, but that sort of grew, right? And I think I just care very deeply about clean air at some very fundamental level. Quality of life is linked to clean air for me, and here I am. And so now I'm half chemist, I'm half meteorologist, and I work on air quality in all different ways. So that's how I got here. It started with a hurricane and being suddenly aware of breathing by smoke in the bathrooms in high school.
And so when we think about how all this comes together and the impacts of breathing and what we're getting into, like right now, it's fire season in the Northern Hemisphere, and skies over places like here in Portland, Oregon are getting hazy because of big fires that are happening in British Columbia, Oregon, all over the Pacific Northwest, elsewhere. And we know that fires, they travel, like the fire from the smoke from fires over here can end up over in the Midwest on the East Coast. What is your work through the years on the troposphere, on the atmosphere, how the dynamics of it work? What is that revealed about the movements and the environmental impacts of these, what we consider seasonal events right now?
Yeah, so wildfires are something that I've been working on for a while. I like to study and understand things that I can see and that I can physically experience, for better or worse, because it helps me understand them at a deeper level. So wildfires, just to take a step back, wildfires are a really great example of what Science Moms, which is the organization where I volunteer some of my time, what us science moms refer to as sort of unnatural disasters right now. So fire is a critical ecosystem process in the Western US. But in recent years, fires are definitely becoming larger, hotter, more destructive. And there's a number of factors that are leading to that. And climate change is a really important one of them. So in addition, we have a history of fire suppression and livestock grazing, and we're also inhabiting the wildland urban interface at greater rates. So all those issues and climate change are making what used to be a natural disaster become an unnatural disaster. And so as burn area goes up, and it has, so climate change has caused almost a doubling of the burn area in the Western US since the early 80s. As we increase burn area, we increase smoke, right? And so smoke is starting to show up in concentrations in places that have not recently seen a lot of smoke, that have not recently experienced that. So you living in Portland, right? You've experienced wildfire smoke. People living in California have experienced this. But as these fires are getting hotter, they're getting bigger, and they're stretching out over longer periods of time, right? That smoke is getting to places like DC and New York, where they're not used to having smoke reach the surface. So as fires increase, we're going to have to deal with the smoke, and more people are going to be breathing it. And as the smoke hits larger cities, larger population areas, the number of people that will experience the health impacts of exposure to wildfire smoke will also increase.
A number of your studies that I saw in the past few years have to do with public health impacts of particulate matter and not necessarily just wildfire smoke. Can you talk a little bit about some of your interest in, like, these kind of personal impacts of how the atmosphere impacts people?
Sure. Yeah. So a lot of my work has focused on the smoke chemistry. So and I'm happy to talk about that, but I'm also happy to talk about how I interact with epidemiologists. And so one thing that's tricky about wildfire smoke is, right, you have this big fire, it's often in a rural area, right? So most of our air quality monitoring networks are set up in urban areas because they've been set up for typical sources of pollution, industrial sources, traffic, right, to protect people often in urban areas, with large sources of air pollution that we understand pretty well in those areas. So wildfire smoke, it's tricky to figure out who's getting exposed when. And is that smoke at the ground, or is that smoke in this big lofted plume that's spread out like a big blanket over areas, or drifting in ribbons? And so what the atmospheric scientists do is we work with the epidemiologists to help them figure out where smoke was and where it wasn't, and when it was there and how much was there, so that they can more accurately understand what happens to that population when the smoke is present. And so that's what my role is on these teams. My role is to say, all right, let's use our best blend of satellite observations, surface observations, and chemical transport models to tell the epidemiologists and the economists, that my team also works with economists pretty routinely now, where the smoke is. And so that they can look and say, okay, here's a Wednesday with smoke, here's a Wednesday without smoke. What was the difference and what happened to these people? And what they find is that at a population level, there's exacerbations of asthma, of COPD, there's a higher risk of respiratory infections, there's more cardiac arrest. When women are exposed to wildfire smoke, particularly we think in their second trimester, though I don't understand why, because honestly, I don't understand how anything alive works. I deal with molecules, right? So
I love that you said that. That's the best way I've heard anyone say that. That's great.
I don't understand that really life. I understand. But we understand that there's some impacts on
miscarriages,
so more early term births, some lower birth weights, those kinds of pregnancy related outcomes. Right. And so people, my job is to help us understand where the smoke is, where it's not, so that we can understand what's happening at a population level. And from there, how do we help people prepare? So what should hospitals expect, for example, when wildfire smoke comes to town? How many asthma medication refills should we expect? Things like that. And so, those are some interesting things that we found. We've also found that, air pollution increases crime rates, right? So particularly like domestic crime, right? We're all cranky. We're like stuck inside with poor air and feeling crappy, right? So
how many people like journey. In places when the air's been really bad and you shut up all the windows? I mean, I put blankets and things in my windows on really bad air days. I'm stuck inside in the dark with my family. How many people just didn't do well?
About 5 or 6 years ago, there were wildfires in California, and it was, I think, the worst I've ever seen in terms of air pollution, because the smoke drifted into the Central Valley and just stayed. And it was all the way to the ground. I happened to be going on a work-related trip on a bus, and it looked like twilight at noon because it was so dark. I remember I took the kids and we went all the way up into the Sierra Mountains and could still smell smoke, but we could look back on the Central Valley as though a layer of fog was covering it. It was so dense. So that should be a good baseline for large population with a long exposure time. I also remember everybody went to go get their...
We did that once, I think, in the summertime, and went to like the casinos in Tahoe together, Justin.
You got to get a higher elevation, right?
Yeah.
So the then there was a run on air purifiers. You couldn't even get through an online ordering system. You couldn't even get them into California because millions of people were trying to buy multiple air purifiers for the first time, which is a good time to bring in our sponsor, the air purification company. We don't have a sponsor? Oh, it'd be a good time for it. But it's really not a bad idea.
Purifier box fan thing.
It's not a bad idea if you haven't needed one or thought you needed one because your air quality is pretty decent. That's a pretty good emergency kit kind of thing to have. It won't fix all of the air in the house, but it was so brutal, the outdoor quality, that the indoor quality was just trapping it indoors. If you opened a door or had a window open and didn't close it in time,
and didn't
trying to get that out of your indoor environment.
If you don't have the proper HVAC circulation within your domicile. So within this, though, the stuff in the smoke, right? Mm-hmm. During COVID, a lot of people got used to buying the N95 masks. A lot of people have them actually on. Like, are these the kinds of things that you've learned are beneficial? Can you still message about these with respect to high particulate matter, PM 2.5 kind of days? Does it matter? The communication aspect, are you involved in that communication aspect apart from just communicating with the teams that you're working on the science with?
So we're actually, I'm co-leading a study right now on how we should communicate around wildfire smoke. And so we're working on right now with communication scientists here at CSU, how to communicate best actions for outdoor workers and also for folks living in manufactured home communities. And so those are two very tricky populations. One, right, there's work to be done outside. And if you're an outdoor worker,
what do you do?
You can't work remotely inside, right? That's not how parks get taken care of. So
that's not how
roads get fixed.
Yeah.
So that's a vulnerable population. And so I don't have all the results of this now, but what we've worked on with them is creating decision trees for that the supervisors can use to think about what the source of air pollution is. So here in the Front Range, for example, we have both an ozone problem. So we have this ground level smog problem, and we also have wildfire smoke. There's two issues in summer, right? And what you might do and how you protect yourself depends on what the issue is, what the actual air quality problem is. And so for wildfire smoke, people are, yes, using a well-fitting N95 will reduce your exposure to fine particulate matter. And wildfire smoke contains a whole lot of other stuff that would not get filtered out by that mask. So wearing a mask is a fine idea. That's not a viable solution for a lot of people, right? It's uncomfortable, it's hot, and maybe it would be better to just take more breaks and those kinds of things, right? Take
Spend
more water
time
breaks,
inside.
avoid more, think about which task you do when, that kind of thing.
There's a question here from our chat.
Ahead.
Do we know what percentage of the burned stuff is in the smoke? So like what chemicals? You say you deal with in chemistry a lot. So wildfire smoke, which is the topic right now. What kind of stuff
is in there?
Talking about?
Yeah, sure. So when you burn something, so fires, you should think of a wildfire as many little fires, actually. So for the listener, I've flown in the NSF NCAR C-130, measuring the emissions from large wildfires. And when you're flying above wildfires and you're kind of looking around, these fires are many different little fires. So you have sort of often this like flaming front and then smoldering sections and things like that. And so how the fire's burning will dictate what is being emitted. But it's a lot of incomplete combustion, even when you have a big flaming fire, because you have all the other smoldering stuff getting sucked into that big column. And so what you have is a lot of carbon monoxide, a lot of carbon dioxide, and on many other what we call volatile organic compounds. So things that are in the gas phase and are made of carbons and oxygens and hydrogens. And there's a lot of nitrogen containing compounds. There's a lot of nitrogen in the fuel. And so you have thousands of different gas phase compounds. And then you have the fine particulate matter as well, which has a pretty complex organic composition. So the particulates, or the sort of suspended solids, liquids, or even things that have like the consistency of honey and peanut butter, those particles have a very different composition than typical urban air pollution. So there's much more organic carbon, oxygens and carbons. That's what most of the fine particulate matter is made of, and very little of some of the more common things that you might find in an urban environment, more sulfates, some heavy metals. So the composition is quite different of the particles and the gases. So smoke is really chemically complex, and it changes really fast with time. So what's emitted is different. It like if you emit smoke, and then as you follow it, sort of second by second, minute by minute, hour by hour, the composition is changing actually quite rapidly. And so the smoke. Yeah, go ahead.
Yeah, Blair's had a look on her face.
When I'm just trying to take it all in. So when you're burning something, and then afterwards there's this kind of like fine sooty substance all over stuff. Is that particulate, or is that carbon compounds that are airborne? Okay.
Well, it was airborne at some point, and the larger airborne components fall out faster. The larger solid or liquid, the particles will fall out faster. They have a higher settling velocity. And the gases don't really fall out. They're oxidized in the atmosphere. So the atmosphere, there's a series of reactions. And so everything in smoke has sort of a different pathway, a different route out. So it depends how each of these compounds interacts differently with the sun's light. So each of them has a differential solubility. So like for some chemicals, rain, whoop, gone. And other things like carbon monoxide, don't care if it rains, gonna keep doing my thing, right? So it depends on how soluble they are, how they interact with light, how reactive they are with some of the sort of major reactive gases in the atmosphere, which tend to clean out the atmosphere. So each compound has like a different lifetime. So the impact, the smoke as it's moving, the mixture is different, and you're exposed to different things when you're exposed to fresh smoke versus old smoke. What's a great example of this that might help you picture what's happening a little bit is when smoke comes to town and that fire is really fresh, you smell it, right? You're like, oh, I smell smoke. I smell that. And when
it smells like campfire all over town.
Exactly. It smells like campfire. Now, I live in Colorado. When we get smoke from Idaho, when we get smoke from California, we get smoke from Oregon, we do not smell it here. And that is because the compounds that smell, they only last about a day in the atmosphere. And so the mixture that we get here in Colorado, people will say, oh, it's hazy. Is that smoke? I'm not sure, right? Because their nose is not the right tool. The stuff that smells is not there anymore. It's been transformed by the atmosphere into other things. And so yeah, smoke is changing, and that's a way that you can sort of tell. Old smoke doesn't smell. New smoke does.
You mentioned the gases that are involved, and when we're thinking about human health and how it impacts people, very often we're talking about particulate matter. We're talking about like the pollution that actually gets in our lungs, and it can impact the physiology. But gases are also, they play a major role in, blood gas, diffusion gradients and the way that we're able to exist as well. How do we know when we can't smell it?
It's tricky.
When we're going to be okay.
Yeah. So we've tried to figure this out, right? So we measure fine particulate matter all over the US, and in urban areas, this is done in a regulatory sense in the US and throughout Europe, throughout China, right? Like there's big networks that measure fine particulate matter. And there's even low cost networks that are popping up. And so what we've tried to do is ratio the amount of these other things.
Not like a Twitter ratio?
Not like Twitter ratio, but like the amount of the other stuff to what is measured. So when atmospheric chemists, when we go out and do stuff, we take like flying laboratories. So we take like a plane and we poke a bunch of holes in it and we measure everything we can possibly measure. Or we take a van and we poke a lot of holes in it. We put a chemistry lab in it, right? And so, but that's not happening all the time in a regulatory sense on the ground, right? We measure like fine particulate matter, that. So, but what we've tried to do is say, okay, let's fly a plane straight into these fire plumes. Let's track that plume downwind. Let's follow it. Let's cross it like we're mowing a lawn. We're going to cross in and out of wildfire smoke, in, out, in, out. We're going to know approximately how old it is. And we're going to say, all right, now when I'm in that smoke, how much benzene is there relative to the fine particulate matter? And how old is that smoke? So we can do that. And we've done that for many hazardous compounds, sort of the gas hazardous compounds, that some of the big ones like benzene, toluene, formaldehyde, acrolein, things that are nasty. And what's good is that we think the toxicity of the smoke relative to the fine particulate matter goes down with age. But it's hard. It's hard. A lot of the chemistry that's in smoke plumes is not measured in a routine basis in our sort of normal air pollution monitoring networks. And so, that probably needs to change to protect people's health.
That's really interesting. It's surprising that we're not monitoring it in a more substantial way.
It's hard.
I mean,
it's just hard. It's hard and it's expensive.
And we're mostly talking wildfire, right? Like, is there a big difference? I would assume, but maybe not, between a wildfire and like an urban fire.
There is a difference between a wildfire and an urban fire. It's somewhat, I don't want to say easy to understand what would be emitted in an urban fire, but if you think about it, you could take my chair or a couch or whatever and put it in a building and light that on fire and know what is emitted, right? Wildfires are trickier, but you know, urban fires will have a lot of other nasty things in them, though, like that wildfires won't, right? There's lots of chlorine and, you know, there's a lot of different things when plastics burn. So, and things like that.
You can smell the difference, at least the first, it turns out at least the first day or so, right?
Yeah.
Between what, like a fire, like, oh, that smells like you can smell rubbers and plastics in there. Then you know, well, that's not the forest smoke. That's a house somewhere or a car that's on fire somewhere.
Yeah, and there's people working on that right now. So there's another faculty member at CSU who's working on better quantifying emissions from fires that also consume buildings. That's not what I've worked on. We did take samples when the car fire, which in 2018, when that was burning houses, we were sampling that plume. But the aircraft sampling set that we had on the aircraft was not set up to specifically look at that. So yes, there may have been differences, and I would not have been able to figure it out given the measurements we were making. So
you would need new technology or new
or different.
Different.
Yeah, different than what I had on the plane. I wasn't, going with the intention of sampling.
You can only poke so many holes in a plane and connect it to sensors before your plane can no longer be.
It's actually not the number of holes. The holes seem to be quite easy to get on a plane, on National Science Foundation planes at least. But it's really weight and power. So you can only shove so many instruments and humans on a plane before you're like, and it's full. No more things can go on the plane.
Our planet is quite full. you also deal with like point sources, right, of emissions. And there are cattle emissions, there are emissions from drilling, and we've got our transitional energies that are going to get us through to when we can be like totally sustainable, blah, 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 blah. What are you seeing and finding with respect to the sources of some of these things? Are they unexpected? Are they things that we can control? Are they things that might be regulatable?
When you think about climate change, right? So air pollution and climate change are intimately linked, but let's put our sort of climate hat on. Fossil fuels. That's it. That's the story. That's where we need to work. That's that. Like,
I mean, there's cattle farts, but it's not that. That's not the big one.
Of course.
It's all about latency, right? Isn't the problem latency?
Well, so it's, yes, cattle fart, and yes, my team is part of teams working to understand methane emissions from cattle and detangle them from the oil and gas fields, because those are happening often in similar locations, right? Oil and gas extraction and cattle farming will happen similar, and it's hard to detangle that. But on the big scale, we need to stop burning fossil fuels. That's it. Like, that is what needs to occur. And there's many ways to do that. And there's many, to use a pen, which I thought of, concrete solutions, because you shared one already in the beginning. Many concrete solutions that already exist, right, that need to be implemented at scale, that need to be ramped up much, much faster. So that to me is not surprising. That's where we stand. Air pollution is becoming tricky, right? We're actually doing a pretty good job in the US of traditional sources of air pollution in many places. And wildfires are really throwing a wrench in that. In places where we've seen improvements in air quality over the last several decades. Good job, Clean Air Act. Now, especially in the Northwest, in Portland, and that whole Pacific Northwest area, you see worse air quality under some seasons, and it's attributed to wildfires. So yeah, but from a climate perspective, fossil fuel consumption needs to be the focus.
And moving from this, concept of wildfires, I grew up in the Smokey the Bear, only you can prevent forest fires era. And now
era?
we're in this.
What do you mean era? I still have a hat with Smokey the Bear on.
They've changed the motto. It's a different thing now. It's like, they switched it up. The messaging's different. But that said, it was a whole thing where it was like, okay, you can stop forest fires. That was it. Now fires are these things that we're not controlling. They're uncontrollable because we didn't do things. Things happen. Nuance. Not going to discuss it right now. But we talk a lot about climate change. We talk a lot about the things that are going wrong, the heat, the fires. People get a little hopeless. And Blair has been really wonderful about bringing solutions to the table. But as working part of Science Moms and also your work, people have I think, been actively disengaged by various forces from the cycles of the ecosystem that we live within and our place within it. Do you have any results of your work that can help people feel more like they're a part of things and that they can do something?
I hope so. I hope that's what Science Moms will do. And it's pretty easy to convince myself of that. So I sit every day, all day, with unnatural disaster research, right? Every day, all day, every seminar, every class, climate change, air pollution, all day, every day. There's no escaping. And even me, like, I can look back and I say to myself, moms fix stuff. Mom stopped child labor. Moms saved countless deaths from drunk driving. Like, moms fix stuff. And so climate change is a man-made problem, is a human problem, is an us problem. We know the solutions. We know how it works. The hat is amazing. that we know Justin has an amazing hat. Only you can work on climate change like you, Justin. So anyway, but moms fix stuff, right? We've done hard things before, and we can do hard things. And so the issue with climate change is that, it's big and it's hard, and there's a tight timeline. And those of you who have small kids, the timeline is the same timeline that you need to get your kids out of your house, right? That sort of the next 10 years, as you plan to bring them through their education and maybe onto college or onto a career or whatever their next step may be, that's also the timeline that we need to move away from fossil fuels. But it's not an impossible timeline. It's just something that we have to decide to do. And parents move mountains for their kids. They do it all the time. And so I actually find that very heartening, and I find it very motivating. And I hope that people can think that way, and not to become demotivated, but to become, okay, let's just do this. Let's just get this done. This needs to move to the top of the priority list now. And here we go. And there's so many ways to contribute to action on climate change. And that's also really hopeful. So the first one is to just talk about it, right? So the more you talk about it, the more people perceive it as important to you, and people that care about you care about things that are important to you. So talking about it is actually doing something about it. It's elevating the issue. Reframe the wildfire smoke, reframe the hurricane that's coming with sea level rise, reframe those as unnatural disasters, as sort of unacceptable disasters that we are not willing to accept that risk for our families. And there are things we can do about it. So that sort of reframing and changing the language around this is really important. You can reach out to your decision makers, just ask them, what are you doing about climate change? As the election comes forward, right? All the progress that the US has made, make sure it keeps going. Double it. I don't care who's in charge. Just keep going. Push hard. Because the next 10 years really, really matter. And then if you're a person who wants to do something yourself, like just do a thing, there's so many things that you can actually do, so many little swaps you can make that decrease, the amount of carbon gases that you're responsible for. So there's just so many things to do. And moms in particular have done very hard things before. And there's no reason why we can't work on this.
And just to speak up for dads.
Yes.
We have witnessed moms fix a lot of stuff. So we get it.
I really
get out of mom's way.
I have a really great girl dad here at my house that does lots of good things, but I am a mom, right? Like that is who I am.
I really appreciate the reframing of the getting away from calling things natural disasters. This is the thing. Whenever there's an earthquake, and it's like, oh, it was a terrible earthquake, natural disasters. Well, we knew there were earthquakes there. We knew there's a fault line under this city, and we rebuilt it up again. So that's still a man-made disaster if you've built a city on an earthquake and rebuilt it there on a fault line earthquake. So
without doing particular
there's a disaster
that would help the
right?
buildings.
If there's disaster that results, it's because of that, right?
Yeah,
and so the unnatural disaster framing, I think, is really important to let people realize that this isn't just an unavoidable consequence of nature doing a weird thing. This has been accelerated. This has been contributed to. This is part of a chain reaction of events that can be controlled.
Yeah, I mean, when I think about half of the burn area is that we have experienced, half the increase that this is a massive amount of the wildfire problem that is unnatural, that we can do better. And it's this unnatural. It is unnatural to have temperatures that are really, really hot, right? Yes, weather changes day to day, but the temperatures we're seeing, the increase year over year, that is unnatural. And so I do think this reframing is really important, and helping people just have confidence in that reframing. That's what Science Moms is hoping to do, to help people have confidence in that. This is not normal.
And with the wildfires, there's also another element of it's unnatural man-made disaster that was usually avoided by a man-made disaster avoidance. So there used to be indigenous burning that would happen seasonally in a lot of these areas, because people who lived in the Pacific Northwest down through California for thousands of years noticed that fires could happen. And so they would do controlled fires intentionally to prevent the amount of burnable areas in the seasons when it became a runaway or wildfire burns would be able to increase. They created fire breaks. They got rid of those tinder areas. And it's something that was stopped under American U.S. law when territories were sort of colonized or taken over.
Yeah.
So
And so we will need a return to more prescribed burning to do anything we can to prevent the most severe wildfires. And that will be something that will require making plans so that people can protect themselves, because that will generate some smoke, right? But we do need more prescribed burning. And so as someone who hates air pollution, right, I also have to accept that to save us from the worst of it, we need to work on climate change, but also there will need to be some more prescribed burning. What scares me the most, though, is that the windows for prescribed burning, as the climate gets warmer and drier, those windows are getting more difficult. So that's the thing that's scary, right? Is that, yes, we have to do more of it. And gosh, it's getting harder to do because we're priming the atmosphere for fires.
Because it's the dry season all year long. And so there isn't that springtime range where you can do a controlled burn without the risk of it really.
And it's also full of carbon dioxide already. And there's only so much that the oceans can balance. And there's all of the stuff, the nitric oxides, all of it. All of it.
So much stuff.
So primed yet. Yeah, moms, we can do it. Blair, you've been sitting here and haven't asked a lot of questions. And as a new mom who is specifically within this time frame, who's also been active in climate change communications, do you have any questions or just anything you want to ask Emily specifically before we kind of finish this interview up?
Well, first of all, it kind of sounds like you might be familiar with Noki, but if you haven't, I think that's probably, it's a very similar handbook. It's the National Network for Ocean and Climate Change Interpretation, and it's a group I've been involved with for about 10 years now, and I'm really happy to hear similar conversations happening, kind of in different groups, because that is how you change social discourse, right? It's the strategy of similar talking points that evoke similar kind of emotional response that encourage people to act. Because the hardest part talking about climate change every day is, well, I guess there's two things. One is the kind of the emotional toll of feeling like you have to pay attention to this stuff all the time, which, oh my gosh, like you're doing it so much that there's probably so much emotional care and self-care that you have to do to kind of keep going and not get beat down. But also kind of, instead of making people disengage because it feels hopeless, making sure they feel engaged, right? So I guess that's really my question, is how do you keep yourself excited and optimistic? Because I know it's very easy to say that in a small conversation, but when you're looking at data every day and you're having those conversations over and over and over and talking to kids who are asking the really tough questions, how do you stay optimistic?
So my family ran from the Cameron Peak fire, which is Colorado's largest wildfire. We were out backpacking, and it was hard after that to continue to talk about this issue. But what I tell myself if this helps you or anybody else, as I breathe smoke, see the fires, look at the data, feel the graphs in a way that I do now that I know what it feels like to be very close to an active wildfire. As I do that, what I say to myself is like, I can learn from this and therefore I can teach. So I've learned from this and therefore I can teach. And so that's what I do as a university professor, is I say, the world has given you these experiences and it's your job to teach about them. And I have 2 kids. So, right, I have 2 beautiful daughters, and I don't want them to worry about climate change, right? I want them to say like, oh, mom's working on that. I need to do my stuff, right? And I also feel that sense of responsibility very deeply. I feel that I do not want to pass this on to them in the mess that it is. I would like our generation to set us up on a path for a more stable planet. And so those are the 2 things. Those are the 2 things I think about learning and teaching. And I think I have 2 beautiful daughters and I don't want to pass the mess. So
I appreciate that. I think very often we think somebody else is going to take care of the problem for us. And it is our responsibility
that's what
not
moms
to pass
are
it on.
That's the whole trope, right? Like,
let's fix it.
That's
your
kind of
mom
my
doesn't
problem,
work,
Justin.
That's
kind of the point, right?
Away. Your mom doesn't work. What does that mean? That means like, that is. It's
moms already are the ones. Most of the time, sometimes managing the grocery lists, figuring out what the kids have to bring to school, having the mental to-do list happening, whose birthday is it this week, and now also climate change. Wow.
Atlas, who had the
busy
weight of the
people get
world
more
on
done.
his shoulders, Atlas was a woman. No.
But busy people get more done, Blair. It's just a fact, right? So like moms are fine to do this. And especially as your kids get to later elementary school, like you have time to also work on climate change. Maybe not when you're nursing and you don't sleep at all, right? But as they get a little older, you have plenty of bandwidth to work on it. And so yeah, I don't know. I feel like our kids are going to endure plenty of hardship. Life brings so many curveballs all the time, so we don't need to add climate change to it.
Means it brings joys.
That's so often the kind of the crutch for environmentalists for generations. I feel like it's been like, oh, kids, they're the hope. They'll take care of it. I feel like I got that too. Oh, your generation has to save the rainforest. I feel like that was big in the late 80s and early 90s. It was like, you kids, you're going to save the rain. What? I got to do? Excuse me? I'm learning how to write my A's right now.
We each have a responsibility, but we do not have to say that it's not like, I'm just going to pass it on like used clothing to my children. I mean, used clothing is great because then you're not perpetuating the consumer cycle, but come on.
So there is individual responsibility that I think was taught to especially the current generations. Everything from recycling to sourcing and vetting where materials come from when you think about it, right? But at the end of that, there's also required a big regulatory change that hasn't seemingly been taught to corporate industry worldwide, which is that, it's important that we recycle, but hey, also maybe not so much plastic being sent our way in the first place. Yeah, it's important to, reduce our carbon footprint, but maybe that means that industry needs to find other energy sources and invest in it, and governments need to regulate the emissions better. Like we've gotten to the point where we've accepted
the message to them. That's what we want.
Yes, that's the next.
As consumers, unfortunately, we have to tell them to stop.
Pass the fight on to the children, but also put the change where it really needs to take place.
Civic responsibility.
So
I'm all about
the thing, though, the civic responsibility is partially about.
I love it.
There's this whole kind of narrative about voting with your dollar that is is incorrect, because so many times companies are like, oh, you want compostable bags? Sure. Just kidding, they're not really compostable, but we're saying they're compostable. But if your civic leader or if your representatives make laws about what materials things can be made out of, that makes a much larger change, right? Because like all the greenwashing out there, people are voting with their dollars for things that aren't any better for the environment, but they're
Just
being
vote
sold
with your
that,
votes.
Right?
Vote with your votes.
Exactly.
Vote with your
Thank you.
votes.
It's
Vote
an
with your
election
votes.
year. Can you vote with your votes, please?
Vote with your votes at every level. And climate action, right, can happen at every level. So it can happen very effectively, and it has to happen at every level, right? It has to happen at the local level, it has to happen at the national level, and it has to happen at the international level, because this is an us problem, right? This is an us problem. The atmosphere has no boundaries, and carbon gases stay in the atmosphere for a very long time once they've been emitted. It doesn't really matter where they're emitted from. So this is an us problem, and this is, you don't have to have the solution. This is the other thing I'd like to just tell everyone. You don't have to have the solution. You have to say it's your top problem, or it's one of your 2 top problems, and you want people to work on it. That's what you have to say. You don't have to say, I think you should do this, and I've added up every carbon molecule and rebalanced the electrical grid. That's the us problem, right? There are people who can do that, and you should say, that's my priority. Work there for the next 10 years. Because that investment will really matter for civilization as we know it. So
for all of us,
right? And it's that reprioritization, I think, that's really important, and just to elevate. And that, because the timeline is so important, there's later is too late, right? Now is the time. It has to happen now. I mean, I'm an introvert. I don't like being on podcasts. You're all lovely, right? But like,
we've pushed your envelope tonight,
right?
And you've been wonderful.
This is important, right? I have to talk about this. I have to talk about this with anyone, my family, my colleagues, my kids' school, everywhere. All the things, all the time, elevate the issue of climate change.
I want to say thank you so much for all the work that you're doing, the scientific work that underlies our understanding of the chemistry of the atmosphere, of how these wildfires are impacting the atmosphere, how the atmosphere cleans itself. Where does all this stuff go? Somewhere, right? And also your work, you've written papers about the importance of mentoring the future leaders so that they are aware of how to be sustainable and honorable as they move into the future leaders of science. So I want to say thank you very much for doing that part of your job. And thank you for your voice here tonight. I appreciate you talking about this.
Thank you. We're the atmosphere's keepers. Yeah. Next generation needs to be strong too. So thank you. Thank you so much for having me, and thanks for talking about important things and fun things.
Yeah, we like fun things. We like serious things. We like to, bounce it around like I don't know, like Denmark under whatever. Sorry, circling back to water and ice issues, but we really do like to take it all over the place and have the good and have the bad and balance it all out. And I hope that you will continue your messaging and go on other podcasts and talk to more people, and that I get to speak with you again sometime, because communicating science is important.
I hope so too.
We'll put links on our website. If there's anything else, just let me know if I'm missing anything from the notes that I had in the show. But otherwise, everything will be on the website for our audience. Is there anything else you need to tell everybody before you go?
I don't. Don't lose hope. ScienceBombs.com. Join. Have a good night.
You too. Have a wonderful night. Thank you so much.
Good night, Dr. Fischer. Thank you for joining us.
Bye.
Night,
Thanks so much for having me.
I can't wait to find out more of the research that comes out of Dr. Fischer's lab. We are going to keep finishing the show because we have some more science stories. It's getting toward that time. Oh my goodness. Oh, wait. This is This Week in Science. Do you like the show? Follow the show, subscribe to the show, share the show. Go to twis.org. You can find our Zazzle link. That's where you can find merchandise that will help support the show so that we can help keep going with all the things that we do with the show, paying the bills, all that kind of stuff. Also, our Patreon is a wonderful place for you to go. Click the link at twis.org. You can give in an ongoing basis so that we get the support that we need to continue keeping on. 981 episodes. How the heck did that happen? We're still going, and we can't do it without you. Thank you so much for your support. It is time, as we come on back to the show, to the lovely part of the show. It's full of little creepy crawly things that stab themselves in the head. Oh, what? It's time for Blair's Animal Corner.
With Blair!
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
I don't have any creepy crawlies today. I have sea lions and horses. It's a very mammal-heavy animal corner today. So first, I have sea lion camera women. I originally said sea lion photographers, but really they're camera women.
Wait,
this
what?
is in Australia. Researchers have strapped cameras to sea lions to explore the ocean. That's pretty much the whole
dive.
Story.
Is that because they dive?
Because they dive. They're predators. They dive. They stay down for a long time. They have huge habitats. And specifically, they used female Australian sea lions because they come back on land. At the time of the year that they did this, they come back every couple days to nurse their pups. So they knew they'd be able to recover the equipment. Genius, if you ask me.
That's amazing, because usually you put equipment on animals in the sea and it's gone.
Right. And so you have a GPS tracker on it, and then eventually it falls off, and then you go pick it up. But if the whole point of this is that they're diving to the deepest undiscovered parts of the ocean, you can't really go pick it back up again, can't you? So the beauty is they were able to follow the tracker, go, oh, Susan's back on land, let me go grab her tracker. So they were able to do that. These tracking equipments, it was camera and tracking instruments glued to small pieces of neoprene that were then glued to the fur of the sea lions. It all together weighed less than 1% of their body weight, so it didn't impact drag, it didn't impact their movement, and the recordings were made over 2 to 3 days. And then when they returned to nurse their pups, they were able to go, oh, all right, Suze, let me get that camera and that GPS tracker back. And so then they were able to watch these recordings. They had 89 hours of recordings in total. They identified 6 benthic habitats off the coast of Australia: microalgae reef, macroalgae meadow, bare sand, sponge sand, invertebrate reefs, and invertebrate boulder. They covered a very broad area, and it was very different than what they had previously mapped, just as humans. So there could be a few reasons for that. The most obvious one being that sea lions go where humans historically have not. And so that's why they saw completely different types of habitat. And of course, this has a really great impact on conservation and research, because this is a new way to reach parts of the ocean that they haven't been able to capture before. They covered over 5,000 square kilometers of seabed. So this is this is a massive piece of map that they now have for the ecological makeup of this part of the ocean. So this is really helpful in figuring out where protected areas should be, how many animals, what kinds of animals you might find in a particular area. So really good information coming from sea lion camera women. They are.
Why camera women and not both sexes?
Because the men don't nurse. So they had to do the females so that they would come up onto land to nurse the pup.
To come back
so
up.
then they could go grab the tracker. Yeah, because the males could be gone for days, weeks, months.
Okay, I get it.
So,
but
yeah.
was it sea lions that you had the story a while back about how they slept and would dive down while they slept and come back up during their sleep? Well, like not really conscious.
Yes, that's correct. So some of this. I don't think it was this species of sea lion that particular study was on, but it's possible that they do too. So yes, if that happened, then the camera work would be very drifty at that time. So they might see kind of a lot of movement just kind of drifting. Maybe they lob to one side or the other, then they correct, then they go back down, they drift for a little while longer. It would be probably pretty calming to watch, I would guess, as opposed to this action shot that we were just watching that was kind of hectic. So
it's very exciting though, because that
brilliant.
sea lion was into it, going through things, trying to find
what a smart way to explore the seafloor too. Just
yeah. And that's the beauty is that sea lions, pinnipeds are fairly unbothered by things. You can tag them, you can take blood, you can weigh them, you can do all sorts of stuff. They're just like, I'm good, back to it.
And in this case, literally the camera was just on their back, glued to it. Yeah.
They were like, oh, that's kind of itchy. Whatever. Anyway, herring, you know? So, yep. So from sea lion backs to horse guts.
It's quite a change.
My last story of the night is all about horse gut bacteria. And I will say this story is not particularly groundbreaking to me. Gut bacteria impacts the performance of racehorses, which the main reason I brought it is also because there's so much stuff going on with the Olympics right now. And we're watching all these amazing athletes at their best, at their peak. And now I just want to know what's in their poop. And that's not a weird thing necessarily. But I just am very curious what the microbiome of these Olympians are, especially because they're all crammed in together. So their microbiome probably starts to overlap, especially amongst teams. And then also that they're all eating the same stuff. It's just, I don't know. It's very interesting. But anyway, the story essentially is that foals with lower bacterial diversity at 28 days old had a significant increased risk of respiratory disease and performed worse in races. Now, where this gets weird, though, is that they collected 438 fecal samples from 52 foals. They looked at the microbiome from the fecal samples.
And so, let me jump in for a second. These are foals. These are not the full-grown racehorse. These are baby horses.
Right. And so they analyzed the respiratory, gastrointestinal, orthopedic, and soft tissue health issues of these foals tracked from birth to age 3. So they are full adults racing in races, getting prizes, getting medals at the peak of their life at 3 years old. These horses are. And so then they also analyzed information regarding finishing position, official rating, and total prize money earnings so that they could then say what kind of athlete these horses were in relation to their health problems, in relation to their gut microbiome. And of course, a healthy gut means a healthy horse, means a better racer. Not rocket science. What I think is so funny, though, is that they have a whole section where they were also looking at foals receiving antibiotics. Shock of shocks, the foals that received antibiotics early in life had a lower fecal bacteria diversity at 28 days old than other foals who did not. Of course. And these foals won significantly lower prize money in their subsequent racing careers. So,
and I think
the idea is
that is a little bit groundbreaking, because I think when you were
I'm going to push back on you, but go ahead.
Because
no,
I think when we're talking about like the athletic diet, or what you're feeding the horse before the race, or what an athlete eats before a run, or whatever Olympic event, whatever the thing is, we think of that in terms of nutrition and diet, nutrition, energy source, and that's the thing that matters. What this is showing is that way before you were competing in an event and eating a specific diet for that event, your gut microbiota in early childhood, for a horse in this case, determined the entire trajectory of your ability to perform as an athlete later in life. Right. And I think that is kind of a big deal. I think that is, I agree. I 100% agree with you. Like, if you had laid out this study and said, what would you expect? I think same as you're saying, like, yeah, that's what I would expect at this point. Right.
There's one issue.
But
here,
I think it's
there's
to,
one
to
issue.
show it, to illustrate it.
Listen. Yeah. One issue.
There's one issue here, which is there is a variable that's not being accounted for. Now, these foals received antibiotics. Either they received antibiotics to treat a disease, so they were already unhealthy. Did that unhealthiness impact them later in life? Or did the antibiotics impact them later in life? Or did they receive antibiotics preventatively? In which case, did the antibiotics keep them from getting sick and not competing later? And so they went on to compete even though they weren't as physically fit as other horses because of the antibiotics. So there is the weird potential for the use of antibiotics to confuse why the antibiotics has caused this result. Because you can end up having the antibiotics be administered in a way that impacts the trajectory of the horse beyond the microbiome.
So then you would have to take the data that's in this study and eliminate completely all of the antibiotic ones, and to see if there's enough diversity in microbiome difference between outcomes to have made the argument still. Yeah, I see.
Right,
that's
but even so, in terms of the individuals who received antibiotics, there's no way to know if the antibiotics and the wiping of the microbiome is what caused the problem.
No, that's what I'm saying. That's why I'm saying you would have to completely eliminate them from the study, which is what the study is, and only look at the ones that never got antibiotics to see if there's a diversity difference.
So they did both. They did both in this study. They also looked at this antibiotic grouping. Yeah. So that's all I'm saying, is that this was kind of their like, and we're even more right because. And that is the part where I take issue, is that this whole antibiotic section is complicated. That's all I'm saying. It's really hard to parse out your variables here. But ultimately, at the end of the day, gut health is body health. We know this. I am not surprised at all that a healthy microbiome leads to better performance in a race, because also ultimately, are you going to run as fast if your tummy hurts? Probably not.
So, but they separated the antimicrobial use versus the non-antimicrobial use. But I just want to see, in the no antimicrobial use, the rankings based on diversity there. That's the part what would be interesting, because I totally agree with you now that you got to get rid of all that other stuff. And then, is there any real difference in that data? And if not, then it becomes...
Yes. So they're saying that there is, yes. Gut health
is still,
and the health of gut bacterial communities very early in life have a profound and enduring impact on health and performance.
Okay. So if you
and I think there are even studies out right now related to the gut health of Olympic athletes, or not just Olympic athletes, but athletes in general, where the bacteria have a beneficial or detrimental effect on performance.
So can I
something recent that I need to go find.
Can I go a little further with it then also?
I gotta go look at the study. I gotta find it. You need to digest it.
No, to suggest that we know there's genetic differences between athletic performance. There's certain genes that are associated with elite athletes, for instance. Now I want to know, and this isn't a study that I'm aware of, the connection between microbial diversity and having those genes. Is there an interplay with the human genome and the friendliness of a diverse microbiota that then perpetuates? Is that what's perpetuating elite athletes to have, these certain genes that even if they're an athlete, they may not be the elite athlete because there's it's something small. It's like a 3% performance difference if you have elite athlete genes. And I'm not just talking about you have the overall build for an event, but on top of that, there's certain genes they found that track whether it's an endurance thing or a muscle building thing, or these little differences, subtle differences that supposedly give an advantage to the elite athlete. I'm wondering now if there's a relationship between those and microbiota, like if there's some symbiotic relationship that is taking place.
Yeah. So an article, and this is, I just found it again. It was published in The Conversation. You can find it various places. I will put the link wherever when I find the link to it. But the idea is that L-butyrate, which is a butyrate conjugated linoleic acid, urolithin A. These are metabolites that can improve muscle strength and endurance. And when you combine that with exercise, diets high in fiber, polyphenols, and healthy fats, when you got that genetic oomph, it's going to help your mitochondria go oomfier. And so that genetics and all of it do work together. And so there is research that works in that direction. I will try and find that link and share it when I can. That's a thing. Justin, do you have another story?
I guess I could. I don't know. I didn't put it in though, and it has pictures, and so now I got to find it real quick. So this is rock art from the Amazonian.
Rock art? I thought you were going to be talking about like little body sizes.
Yeah. Okay. Oh, yes. This is Homo floresiensis. Well, they've been trying to figure out where does Homo floresiensis come from, and the leading theory has been Homo erectus island dwarfism. So there's been challenges to this because there's also a competing hypothesis that it could have been an earlier hominin ancestor that had gotten to the island that was already smaller. And so it wasn't so much of an island dwarfism aspect, but more a smaller version of hominin that took root there and then just evolved. They have found a arm bone, a small bit of arm bone and a couple more teeth. These are dating to about 700,000 years old. Now, the initial Homo floresiensis finds are somewhere between 60,000 to 100,000 years old. So this is a much older, very small. In fact, it's something like 9 to 16% smaller of an arm bone than you would expect to find in Homo floresiensis hobbit. So it's a much smaller arm. It's much smaller, likely hominid. Homo floresiensis, these hobbits, already 1 meter tall. Very small. Whatever this is, 9 to 16% smaller. The cross-sectional analysis of the bone suggests that this is an adult. This is not a child or adolescent hobbit.
Or an underdeveloped individual.
Or underdeveloped individual, right? They suggest this is a Homo. Now they've already found this is confirming things because they have found stone tools of this age previously that indicated a much deeper history of Homo floresiensis and some teeth. I think that they also attributed, but they didn't know. Maybe it's Homo floresiensis. Maybe it's another branch of something. This is making it look much more like Homo floresiensis has persisted for 700,000 years on the islands. Now, one of the things this would point to is, hey, it's even smaller. So this suggests that Homo floresiensis has been getting bigger. So maybe this is one of those earlier, smaller offshoots. So one side's hypothesis is being reinforced. On the other hand, or actually arm, there's no twisting in this bone, which suggests that it was not arboreal, that this was a biped. This is not a tree dweller. This is not something that has,
it didn't have to have the strain upon it, like that hanging from branches that twisting in the bone requires.
Morphologically, this looks more like a shrunken Homo erectus. So,
island dwarfism.
It's evidence for both, in a sense. It's given both a data point. If you cherry pick them and you believe only in one side or the other, you have found your data that you needed. Except it also doesn't. They also have conflicts, right? So it's just more fascinating. And now we need to find something that's even older, or more of this age, to confirm and fill out the picture. But it would be very, very early Homo erectus. Also, there's no signs of the smaller, earlier hominins leaving Africa before this. But it's also starting, now we're getting into a framing of Homo erectus existing in Far East Asia and getting to islands and then shrinking on timescales much further back than we had anticipated. We know the latest surviving Homo erectus in its full form remains are found in Southeast Asia. We know, and on these islands even. But now it would have to push back even further the time frames in which you could not just get down to Homo floresiensis size in an island dwarfism scenario, but going 600,000 years back from the earliest evidence of Homo floresiensis, we would have to have gotten even smaller. And so that means then you would have to go back even further in time than the current estimates of how Homo floresiensis could have reached this state of island dwarfism, pushing back then how Homo erectus, how much further back in time it would have needed to have gotten to the islands for this scenario to have started to unfold. So this little arm bone is enough to shift time frames of Homo erectus existence in Asia back hundreds of thousands of years, or for at least for the islands of the island dwelling version of Homo erectus, many hundreds of thousands of years. So it's just pushing that whole story back even further. And then the last one is really quick. It's Justin taking exception to archaeological interpretations of art.
Ha.
Now the link should now be in there, and we can bring up some of these pictures. But the thing is,
quick. Blair has to go to bed.
This is really fast. This is researchers finding conceptual art created by Amazonian culture some 12,000 plus years ago suggesting complexity of Amazonian relationships with animals as they had supernatural connections and ritualistic aspects to the art as they are being interpreted as animal-human sort of cross hybridization of imagery in this. And I don't know if you can bring up those pictures if that's visible in the thing. Okay, so this is the overall picture, and as you can see here, there's lots of interesting and crude pictures of things that can look somewhat animal-like and seem a little bit strange. The one that's sort of sitting there with feet, a nose, and kind of like spiky hair, they're calling a plant-animal-human hybridization image. It kind of looks like a crude picture of a two-legged bird, right? Like it's so hard to hear people interpreting art in the modern age. It's like can be brain melting. They've created ritualistic hybridization eventy things for all of these as though they're human animal morphs. And likely when I look at them,
I see interpret toddler art. And into what they think they're drawing. Yeah.
But even just looking at this,
that's mommy.
like there's three things going on. One is if you're drawing a lizard from memory, as if we're looking at the images, B might be some sort of a lizard or salamander type thing. You might give it more human looking feet because I had something down there, but now I'm writing it from memory. And also we can all relate on what feet look like. So I will make a representation of this. You know, the bird that looks like it's bipedal could just be a bird in flight with its talons down. You know, like all of the interpretations that they decided upon can easily be rejected by walking into it without any bias. And so anyway, this is Justin has a pet peeve with interpreting art but with archaeologists interpreting art as ritualistic and not merely objective attempts to render. Not everything in the past is a ritual or spiritual in nature. This could just be an early biologist documenting to the best of their artistic ability what they've seen. A catalog of sorts.
That's fair.
Yeah. Don't add to it without data. Don't interpret it with your feelings. Just back off a little bit.
Well, that's the thing.
Not everybody, if you didn't have paper to practice drawing for years and years and years before you did illustrations, this might be what your best attempt at just capturing reality would look like.
But maybe someday, thanks to research currently going on, we will be able to transmit our feelings and thoughts from brain to brain in natural conversations.
I'd like the conversation without all the feelings. It's already too much.
Yeah, maybe. Anyway, research in Neuron this last week, it's an open access journal, has recorded intracranial recordings between 5 pairs, dyads, they say. These are people with epilepsy who were undergoing surgery and other things. Anyway, they had face-to-face.
By the way, I'm always suspicious of this at this point. There's always epileptics undergoing surgery that have as long as we're in your brain, you mind if we do 3 different research studies? Fine, it's every time. Fine
all the time, whatever. Anyway, they got 10 people, 5 dyads to talk to each other face to face, and they recorded from their brains as they were doing a very common speaker listening modeling framework. It's a thing that's done in research regularly. In this coupling, they were able to record the timing and the electrophysiological signals from the speakers and the listeners, and able to actually determine when a speaker was saying something and when a listener was receiving it. They were able to create a Venn diagram based on the encoding of the within speaker activity, the within listener encode. They created a model that could put it all together, predicted activity based on the actual activity that led to this particular study, which they were able to say large language models. This is not artificial intelligence. It's an algorithm that is based on large data sets of language, modeling a linguistic space for communication. That this could potentially one day allow embedded components within listeners and speakers within the brains of people to be able to convey word by word actual ideas, natural conversation, without ever opening your mouth.
So here's the question. If you're telling me about a trip to Cinnabon, and you were excited because you love Cinnabuns, and then I, who abhors the smell and taste of cinnamon completely, can't stand it.
Yeah, I know.
If you're telling me the story about enjoying cinnamon, would I be getting triggered to enjoy it along with you, or would I be having a very different visceral reaction to not liking it because of...
It's a conversation. They're modeling brain-to-brain conversation, not actually... It's the linguistic coupling, not necessarily the word cinnamon. You go, I'm like, yum. But it doesn't matter. I could say it. You still feel the same way. We have spoken words that convey a feeling. You react your way.
Your brain just hears Kiki went to Cinnabon and enjoyed it.
You go in your head, I'd never do that. But you hear the story and you go, okay, Kiki went to Cinnabon and enjoyed it.
That's the talking one, right?
And you judge me.
Right. But then the brain to brain.
You're sensing her emotions. But it's not now your emotions. It's, Kiki was happy.
Yes.
So that's the brain-to-brain communication, is I would get that Kiki was happy.
Linguistic complexity.
Removing the linguistics.
Coupling, the linguistic aspect. Not merging the brains to make you be me in my brain. It's then, just so that we could you imagine talking to people with... Did you hear what I just said? No, you didn't.
Yeah, actually, I heard everything. Oh my gosh. Stop. Like, my brain is like, I don't know if people would understand my brain. I think it might come out as like...
And so that's the complexity, right?
Because I'm not thinking one thing at a time.
But we have large language models that are now able to understand contextual aspects of phrases like cold as ice. Being like, you're conveying something about a person. Oh my gosh, she was cold as ice. But you're not actually saying she was like in a freezer cold as unless it's part of the conversation, right? So the large language models need to understand the electrical encoding that comes from the language and emotional processing parts of the speaker, and also go to the listener to allow the right things to be conveyed without the use of the written word. Exciting. They're working on it. Very interesting to me. I don't know, Blair. Would you put something, I don't know, like an earbud in your ear?
No, absolutely not. No, because you're just describing right now, like, we're just a hop, skip, and a jump away from something that could be in somebody's pocket and they could record what I'm thinking.
If it's electronic, of course they could. And then can you still employ the little white lies that allow
That's the
civilized
other problem.
society
I will
to
once again
move
say,
Yes.
forward without
Absolutely,
all of
because
these
it's
built on
linguistic
lies.
evil
content. It is
realities of
not
hearing everyone's
you
stuff.
in my brain. It's linguistic content. This is not.
I still don't
Okay,
know.
but Kiki, here's my
You might
follow-up
have better
question.
mind control
people-
internally than I do.
It's so not. Go ahead,
For
Blair.
the people that have an internal monologue,
How
that's
many voices?
linguistic. So this is my question. So I have an internal monologue. When I'm doing something, I'm thinking how I'm doing it in full sentences. Like I'm talking to myself, like then I'm gonna get the flour, then I'm gonna get the sugar. So if that's linguistic, the way that I'm experiencing it, and I am thinking in complete sentences, then someone could use this technology to find out what I'm thinking.
Or
What are you hiding,
you
Blair?
activate it like a cell phone, except it's not a cell phone. You're like mental ring, 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 and Blair's brain goes do, 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 Kiki's calling, and you say those sentences in your thought in your head, but there's a filter because there's got to be some kind of filter. There's got to be some kind of filter.
There better be. There better be a send button.
Be some kind of filter.
There'll be a review and then a send button.
Is like,
and then that's going to slow things down.
Does this really work so that if I'm on the phone with Denise and I'm thinking like, oh man,
is Denise your boss?
Ugly shirt. And then like, but
yeah,
no, I don't know it.
The little white lies.
Perfect. They're like,
exposed.
Oh man, Denise's shirt is just so ugly. But don't tell her that. She obviously really likes it. She said she was shopping for it over the weekend. Tell her she like her shirt.
How do you like my shirt, Claire?
What does she hear?
Denise says,
what does she hear? Does
she know that I can hear that? I
yeah.
can't believe she doesn't like my shirt. Oh my goodness, that's so rude. And I did just tell her that. So she was listening, but she still is thinking this. Can she hear? Oh no, can she hear me now? And then Blair has to say, yes, I can hear you. I'm so sorry. Like this is a horrible conversation.
This also becomes very interesting when we start taking into account people who do not have inner voices, people who only have one inner voice. They're just the one. And then people who have multiple inner monologues, constantly competing, talking to themselves about all sorts of things, and then talking to the outward world. I
have multiple voices, but they're all mine.
Oh, no. All my voices are mine. There's just a lot of them in there.
It's
so how does that come out?
Conversation with the self thing going on when I'm in a mental debate about something. It's
philosophy.
Me arguing with me in my head at the time.
How many me's do I argue with on a daily basis? That will be the subject of our next discussion. No, speaking of earbuds, though, there's a cool new earbud. Last story for the night. Researchers at UC Berkeley have been inspired by the AirPod and the idea that you can have these little things in your ears that not only put sound waves into your ears that you can sense, but now they are using the earbud as an EEG. And in this new study that they have just published, they have shown that they are able to use the EEG detection of wireless ear monitors to figure out when you're sleepy and when you're going to like maybe fall asleep. So you're listening to music, you're on a walk, you're driving a truck cross country, whatever it happens to be, or maybe you're epileptic and, or they're whatever. You got your earbuds, going for a run. Who knows? Maybe they could save your life. The idea is that they have been able to implant technology into the small devices that we put into our earpieces to monitor drowsiness so far. And it's integrates with pretty generic technology, wireless electronics, and offline classification algorithms. So it doesn't have to be online. It can actually be either in the earbud or probably in your phone. or in your car. And the data that they recorded across a number of subjects led to them suggesting that they had an accuracy of 93.2%, which is pretty high. So perhaps someday you'll be able to pop in that earbud and go for a ride, as opposed to, you're not supposed to really wear headphones or earbuds while you're driving, but maybe the technology will be beneficial one day.
What does it do if you're falling asleep? Play
I
an
hope
alarm
it does
sound?
that, like,
scare you so you run off the road for that reason? Yeah, exactly. I feel like that's more dangerous.
Right?
Deliver a small electric shock. How about that?
It seems like that would be really helpful. Yeah.
Yeah, I mean, if you're driving, you don't really want to be scared so that you swerve into another lane and have an accident. There is the response of how it wakes you up to keep you from doing that. But the researchers, I think,
alternatively, it could simply communicate to your vehicle that it needs to pull itself over and stop.
When we have all the vehicles that are completely
that there is no longer a human minder involved,
or partially,
and then you'll get pulled over. It's like, oh, you know why I pulled you over? Oh no, why is it, officer? Because you're not wearing your earbuds in a self-driving car, and that's the law. You have to have them in.
So far, they're very small. They look like they look like cochlear implants, kind of. They're like very, very tidy in-ear devices at this point in time. Maybe they just vibrate within your ears. Maybe there's something. But the potential for protecting people, it's the beginning of using the technology we're already using, as opposed to creating new things that we need to be paying attention to. Use what we've got, right? To help us do better. And on that, I am sensing that Blair is tired and past her bedtime.
Very much.
Yeah. Have we done it?
Yes.
I think we may have come to the end of yet another episode.
Did we do? We've come to the end of another episode. Oh, everyone out there, thank you so much for joining us tonight. Special thanks to Emily Fischer from Colorado State University, Fort Collins, who joined us to talk about wildfires and atmosphere, troposphere, and science moms. And we'll have links to all of that on our website for those of you who are interested. Science Moms is actually an organization started by Catherine Hayhoe, who is a very prominent climate researcher and communicator. And in this, I also do want to say thank you to the special people who helped the show. My co-hosts, Blair and Justin, also to Fada. Thank you so much for all of your help with show notes and social media. Identity4, thank you for recording the show. Gord, Arenlore, everyone who makes the chat rooms very social places that are nice places, safe spaces to be. I really appreciate that one. And all of you in the chat rooms, in the Discord, everywhere, thank you for being with us and talking. Mike Owens, thank you for that donation of $20 tonight while we did the show. Really appreciate that. That was a huge, huge thing that I very much appreciate. And to those of you who are patrons, I would like to say thank you. Thank you to Eden Mundell, Alan Viola, Aaron Anathema, Arthur Kepler, Craig Potts, Mary Gertz, Teresa Smith, Richard Badge, Bob Coles, Crent Northcote, George Chorus, Pierre Velazarb, John Ratnaswamy, Chris Wozniak, Vegard Shefstad, Don Styles, a.k.a. Don Styles, Ali Coffin, Reagan Shubrew, Sarah Forfar, Don Mundis, P.I.G., Stephen Alberon, Daryl Myshak, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hessenflow, Sean Leisman, a.k.a. Z. McKen Hayes, Howard Tan, Christopher Rappin, Richard, Brendan Minnis, Johnny Gridley, Remy Day, G. Word, and Lattimore, Flying Out, Christopher Dreyer, Greg Briggs, Oh, I think you're on your way home now. Good luck with that. John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, Lon Makes, EO, Adam Mishkan, Aaron Luthen, Bob Calder, Marjorie, Paul D. Disney, David Simmerly, Project Pecoraro, and Tony Steele. Thank you so much for all of your support on Patreon. For those of you who are interested in supporting us on Patreon, please head to twis.org, click on that Patreon link, and find your place within the Patreon community. Any amount does help. On next week's show,
we will be back 8 p.m. Pacific time on Wednesday, 5 a.m. Central European time on Thursday, broadcasting live from our Twitch, our YouTube, and Facebook channels.
Want to listen to us as a podcast? Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here today, show notes, links to the stories will be available on our website, www.twis.org, and you can sign up for a newsletter if you choose to.
I have thoughts.
We love your feedback. If there's a topic you would like to cover or address, or a suggestion for an interview, please let us know on one of our social media accounts. Maybe, I don't know, they're kind of sporadic now. Or what's better is you can just send us an email. Just be sure to put TWIS, TWIS in the subject line, or your email will be burned to a crisp and aerosolized into particulate, and then hopefully not breathed in by somebody with TWIS. We'll never hear it. So just put TWIS in the subject line.
We look forward to discussing science with you again next week. And if you learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views. But I've done the calculations and I've got a plan. If you listen to the
And Blair is so tired because she got up so
I was going to
early.
leave and Justin left, and I didn't want to leave you alone.
I really appreciate that.
I was like, I'll just go. They could do the outro after show stuff without me. And then left.
And then it would just be me. Oh my gosh. You know, for half the show, I've had like a plugged ear. It's a really it's a thing.
Right. Okay. Well, on that note,
I haven't tested positive for COVID, but I don't feel great. So I'm tired too.
Everybody go get rest. It's late where you are, and I have a whole day of doing stuff ahead of me. So it's fine. We can call it the early after show. We had a great long show. We had amazing guests.
Amazing guests. So many questions still to be answered, but there always are.
Questions.
Blair, thanks for staying up late. Get some good sleep.
Yeah.
I hope your baby gets some sleep too.
See you guys next week.
Night.
Justin, get some good work done today. I'm gonna get some good sleep as well. And hey, I'm Finny.
See you next week.
Everybody, stay curious, stay healthy, stay happy.
Stay lucky.
I ain't satisfied. Yeah, stay lucky. Please come back next week. It's like Cheers. Come on back. I don't know. It's an old TV show. Come on back now. You hear?
80s at a bar.
I'm Fitty.